Hello guys, if you remember, during the previous video, counter instructions were explained briefly. After that, the connection process between CODESYS and Factory IO was explained, to test an up counter. In this video, I'm going to do a more practical project which will use counter instructions. During the project, RS and SR instructions will be explained too, which are used to set and reset variables. Also, I'll show you how a positive or negative edge can be detected. Before we get started with today's video, I just wanted to inform you about all the great content we have been releasing on the PLC-goods YouTube channel, which includes industrial automation PLC programming, HMI, and microcontroller-based developments. My name is Syed Reza, and if you enjoy this video, I would appreciate it if you could click the subscribe button as well as the notification bell, to receive the latest and the greatest content I will be posting through the channel. Well, let's start this video with the final project. My program has been connected to the system. So, let me use the start push button to run the system and see its performance. In this project, the boxes are separated based on their height. The height of boxes can be detected by the sensor. It is a light array and includes these three sensors to detect pallets, and also small and large boxes. Okay, the chain transfer is directing large boxes to its left side and small boxes to its right side. Let's press the stop push button. As you see, the entry conveyor has been stopped immediately, but the left conveyor will remain on to move its boxes. Again, let's press the start push button. Naturally, if the emergency button is pressed, immediately all devices must be stopped. As you see, the number of moved boxes can be seen here. It can be reset by the reset push button. Alright, let's see how the system can be designed inside Factory IO. In this project, I've used a predefined system, without any changes. So, you can use it too and write your program, then compare it with mine. Maybe this light array emitter, and the chain transfer are the main equipment in this project. The chain transfer has 4 actuators. The load actuator is used to receive boxes from the entry conveyor. Also, these 2 actuators will be used to send boxes to the right or left side. Well, the light array emitter can be used to detect boxes. In this project, I will use it to detect pallets, and also small and large boxes. I'll explain other sensors and actuators during the programming step. So, let's launch CODESYS to start programming. Like the previous videos, let's create a new project. Okay, let me add a simple coil to my program. I will connect it to the entry conveyor. Likewise, let me add the next coils for the other actuators, which will be used in this project. Alright, I've inserted one simple coil for each actuator. A simple way to programming is determining all conditions that turn on an output, otherwise, the selected output will be off automatically. As you know, PLC executes the whole program and then update all outputs. Therefore, if two different programs are written for one output, PLC will work based on the second one. So, try to use one coil for each output. OK, an important condition is, which push button has been pressed. The start or the stop push button. So, let me save the start-stop request on a bit of memory. Like one of the previous videos, a set or reset coil can be used to save the start request. In this project, I want to use a simple coil, with an SR or RS instruction. Let me use the RS. As you see, it needs a variable whose data type is RS. Also it has two inputs. The first one only set its output, and the second one only reset it. Similarly, the SR instruction has two inputs, but there is a little difference between the RS and SR. If both inputs are activated, the RS instruction will reset its output, but the SR will enable its output. Now, let's use the RS instruction to turn on or off the entry conveyor. Naturally, the program must turn it on when the start push button is pressed, and stop it by pressing the stop push button. Note that, my stop push button inside the factory I/O is normally close. So, to work my program correctly, I must use a normally close contact for that. As I mentioned before, all the conditions that can stop or start the entry conveyor must be considered. When a box arrives here, the entry conveyor should be stopped, until it moves to the right or left side completely. The loaded sensor can detect the box on the chain transfer. So, let me use it to stop the entry conveyor. Assume this is the receiving signal from loaded sensor. I want to stop the entry conveyor at this moment. So, let me change the normally open contact to this form with a P letter. Now, it is sensitive to positive or rising edges of the selected digital input. After that, if the system is still in running mode, and the box has been moved to the right or left side completely, the entry conveyor must be turned on. Note that, there are two sensors, at the beginning of these two conveyors. I can use their pulses to detect the box has been moved or not. Note that, by default, these two sensors are activated, until a box is located between them. So, their receiving signals are like this. Again, I need to detect this rising edge, which indicates the box has been moved completely. Now, let's determine when the load actuator must be turned on. It receives boxes from the entry conveyor. Note that, the pallet sensor detects all boxes. So, I can use it to turn on the load actuator. Note that, the system must be in running mode. Finally, this sensor whose name is loaded, can be used to stop receiving boxes. Now, let's write a program to control the load actuator, whose task is receiving boxes from the entry conveyor. Now, the chain transfer must decide to move the received box to its right side, or to its left side. So, let's write a simple program to detect the type of the box. Alright, based on this part of my program, if only the low sensor is activated, this memory, box_type, will set to 1, to indicate the current box on the chain transfer is small. If the current box is large, both sensor will be activated. Because I've used RS function, the output will reset to 0, to indicate the current box is large. Let's continue. The transf_right actuator must be turned on. When the loaded sensor is activated, it means a box is located on the chain transfer, and also if the type of box is small. OK, when the box has been moved to the right side completely, this sensor produce a positive signal H. Let me use that to turn off the transf_right actuator of the chain transfer. Similarly, let's write a program to move large boxes to the left side. Let's continue and write a program to turn on the right conveyor. Note that, 2 sensors were installed at the beginning and at the end of the right conveyor. I can use the first sensor to detect incoming boxes, to turn on the conveyor for a specific time to move boxes, using timer instructions. If you remember, counter instructions have been explained during the previous video. In this project, I want to use counter instructions, instead of timers. So, let me add an up and down counter. Now, let me use the first sensor to counting up, and the second sensor to counting down. Therefore, the counter will count the current boxes on the right conveyor. Note that, I've used the negative pulse of the first sensor. You may want to use positive pulses. Now, let me use the reset push button to reset the counter value. Well, I don't need the load input, but it cannot be empty. So, let me write a variable such as nu0. It won't be used or changed in my program. Finally, I enter number 1 as the predefined value. As I've mentioned before, this counter count the number of small boxes, which are located on the right conveyor. So, when its value is equal or greater than 1, the first output will be on. In consequence, the right conveyor will remain on, to move all small boxes. Similarly, let's use some variables for these outputs, which won't be used later. Now, let's write a similar program for the left conveyor. Alright, let's have another network, to use an up counter, to count all boxes. I can use the pallet sensor to detect all boxes. Again, let's use the reset push button to reset the counter. So, it has been used to reset the 3 counter values, which have been used in my program. OK, for the last counter, its third input is not important, because I don't need the first output of the counter, but I'll connect the counter value to the digital display on the control box. Okay, the first version of my program has been completed. Now, let's start from the first and add the emergency push button to my program. First, let me correct this contact type. Because the stop push button is normally close, I must use a normally close contact here. Similarly, let's use the emergency button beside the stop push button to reset the running variable. Now, let's use the emergency button to stop the entry conveyor. The next actuator is load of the chain transfer, which receives boxes from the entry conveyor. Let's use both stop and emergency buttons to stop it. Likewise, let's use the emergency button to stop other actuators immediately. Note that, the reset input of the counter doesn't reset the right conveyor. It just reset the counter value to 0. But because 0 is less than 1, automatically, the counter will stop the right conveyor. Alright, the second version of my program has been completed. I've tested this program before, and realized these two actuators must be on a little more. So, let me add 2 off delay timers before them. Note that, this off delay timer makes the emergency button cannot stop this actuator immediately. So, I need to use its normally open contact here. Similarly, let's add an off delay timer and an emergency contact to the next network. Alright, this is the final version of my program. Note that, I've not written the whole of this program directly. I've started with a simple program, and then improve it 2 times. Maybe you want to improve it again. Well, the next step is testing. The first way is using simulation mode, under the online menu. Now, I can test my program, but I have to change the state of all push buttons and sensors manually. It's a little hard. So, let's exit from the simulation mode, and connect my program to the design system inside Factory IO. Note that, the connection process was explained during the previous videos. Especially these 2 videos can help you. Now, I'm selecting which variables must be shared with Factory IO, through my OPC server. Like the previous videos, let's launch CODESYS Control Win v3 as my virtual PLC, and then download my program. Alright, my program has been downloaded and started successfully. Let's connect it to my OPC server. Like the previous videos, I've defined these tags inside the OPC server, to connect my program to the equipment inside Factory IO. Now, let's connect them to my OPC server. Note that, I've used the equipment name, for defining tags inside the OPC server, and also creating variables during the programming step. Now, I can connect the equipment to the defined tags correctly. Now, I can test my project. Remember, the project has been tested in the beginning. I hope you enjoyed this video. Thanks for watching my content. If you have any question on this topic, make sure you leave them in the comment section below, and if you can spend a few seconds of your time liking as well as sharing this video, if you enjoyed it, that will mean a lot to me. If you have any suggestions for the channel, such as what kind of hardware or software I should be covering, then make sure to leave that in the comment section. See you next time. Bye bye.